Good morning, boys and girls. I think now we can move on to the tors. We can move on to the tors. That is the landscape that we are going to look at now. That is the tors. We can look at the tors, which falls under features of intrusive volcanism. Features of intrusive volcanism. That's what we are going to look at now. So we are saying now, when some of these landscapes are formed, okay, in terms, let me just talk about intrusive igneous rocks, okay. We are saying now within the crust, you remember that the crust, okay, this earth is made, it has got a structure. It is made up of the mantle, it is made up of the core, which is the inner and the outer core, the mantle, and also we have got the crust. So we have got the rocks that are formed, okay, the landscape that are formed within the crust, okay, within the crust, which means now when we look at our earth crust, we have got something like this. We have got the crust, we have got the mantle here, okay. We have got the core, which is made up of the inner core, and we have got the outer core. So what usually happens is the rocks that we have within the mantle, they are in molten state, which means they are in liquid state. So what it simply means is that the movement that are within the earth crust, what they do is they result as a result of volcanism, okay, as a result of plate tectonics, the movement of plates. They either move away from each other or close to each other. They can also be earthquakes. So what happens is there can be a line of witness that created within the crust, which means whatever is within the mantle now is forced to come out, either to slightly below the crust or on the surface. So when you talk about intrusive now, because this is where how the tors start, okay, so we are talking about things such as, I think I've got a diagram that I'll show you, okay. So we are saying now, when we talk about mostly the intrusive one, we are talking about things such as your batholith, talking about such as your dike, things such as your laccolith, such as your what else, your lapolith and your loccolith, and also your seal. So this is what is formed within the crust. They are intrusive because obviously when the molten magma moves from the crust, from the mantle towards the crust just below, the temperatures are different. That's basically what we are saying. So when it moves from the mantle just below the earth crust, the temperatures are different. So it starts to solidify, resulting in different landforms. It starts to solidify, resulting in what we call the intrusive igneous rocks. Of course, the intrusive features, of course, that's when we talk about things such as your batholith. Of course, this is how it looks like. Of course, from the batholith, we can end up having different kind of landforms, okay? This is when we end up having things like this laccolith. Of course, we can also end up having a lot of landforms like your granite domes as well. Same applies from your batholith. So this is maybe through volcanic, okay, when there's a volcanic eruption. Remember, now a line of weakness has been created, which means whatever is in molten state within the mantle is now forced to come out. As it comes out, it is slightly below the earth crust, and below the earth crust, the temperatures are different as compared to what they are like in the mantle. So in the crust now, just below the crust, this is where we end up having all this. This is within the crust. That's why we call them intrusive. This is within the crust. That's why we call them what? Intrusive. You have got your batholith, you have got your dike, you have got your laccolith, you have got your seal, you also have your lapolith, which is kind of saucer shaped. You also have your lapolith. Okay, so these are the different types of intrusive igneous rocks or intrusive features that we have slightly below the crust. Okay, why? Because when molten magma moves from the mantle, just because the volcano is erupted, it means now the temperatures are different. So we end up having this different kind of intrusive features. Okay, it is from these intrusive features that we end up having what we call the tors. That's basically what we are talking about. So assuming that we have, this is within just slightly below the earth crust, we have a lump like this, okay, which is more like our batholith. Okay, batholith. Okay, so we have this within the earth crust as being intrusive. So what happens now is, since it's now slightly below the earth crust, it's now there's changes in temperatures. So which means they are bound to be joints forming They are bound to be joining points. The joints forming, it can be horizontal and vertical. It can be horizontal and vertical. Why? Because the molten material that is slightly below the crust now, it is now solidifying. As it is solidifying due to difference in temperatures, there are cracks or faults or joints that develop. Remember, it's from molten within the mantle. Now, below the crust, what is happening now is solidifying. As it is solidifying, there's changes in temperature. Okay, so it can also result in the formation of the cracks and joints, of course, that we have, which can be both vertical and horizontal. So this horizontal joints, of course, with erosion, the passage of time, you would find that this rock outcrop will be exposed. But what will happen is there's more of chemical erosion, which means we are going to have chemical erosion. Okay, think of chemical erosion. Remember, the rock is made up of different chemical components, okay, mineral components, of course. Let me talk about the igneous, feldspar, mica. Of course, this forms part of igneous rock, so they react differently to weathering. So we are saying now these joints now, through chemical weathering, we end up having the core rocks exposed. Okay, we end up having core rock exposed due to erosion. So when it comes now to the earthy surface, already it has got vertical and horizontal joints. So when it comes to the earthy surface now, we are going to end up with a landform like this, because this has developed whilst it was inside. So it develops through the joints. There's chemical weathering that has taken place by water seeping through. Water seeps into the vertical and horizontal joints of igneous rocks, and chemical weathering take place. So the mass of igneous rocks broken down into rectangular blocks, like you can see here, what I've demonstrated. Okay, the joints are widened. As a result of the rocks are reduced in size and become more rounded, of course. Then when the overlying material has been removed by erosion, so this is going to be removed by erosion, everything, this is going to be removed by erosion, then we are going to end up with this top. This is your top. That's basically what I'm talking about. This is your toe. This is how it is formed. It started formed from an intrusive, like your batholith, like your laccolith, the one that I've shown you, your batholith. You can see this is your batholith. You can see this is your laccolith. So it can be formed from this. It's still within the earth crust, but however, still is within the earth crust, just above the mantle, which means the material that makes the batholith and laccolith used to be in molten or in liquid state. But just since there is volcanicity that has happened, which means it has forced that material to come off the mantle and be slightly below the crust, and it solidified there, resulting in batholith and laccolith. And it is from this batholith and laccolith that we have got your granite dome. We have also have your tors. That's basically what I'm talking about. Okay, let's go through the question now that you have got an idea. So what are tors? Okay, this is a mass of loose core stones. This is a what? Mass of loose core stones. Okay, you can see it's also known as a copy. This is a mass of loose core stones. This is what a tor is. This is a mass of loose core stones. That's what it is. Name the rock type from which tors develop, evident in the sketch. We have talked about. This is an igneous rock. Igneous rock. We know the different types of rocks that we have. We have got the igneous rock, we have got the sedimentary rock, we have got the metamorphic rock. This is cretan stuff. So this is an igneous rock that it develops from. Okay, then we have got state the igneous intrusion from which tors originate. Remember, I was talking about the igneous intrusion that are formed within the crust. Of course, I talked about the batholith. Remember, I talked about the batholith. It can develop from a batholith or from a laccolith. It can develop from a batholith or a laccolith. That's where it can develop. Remember when I was explaining? So it can develop from a batholith or a laccolith. It can develop from any of the two. Then discuss the role that igneous intrusions play in the formation of tors. What role do the intrusion, that is your batholith and your laccolith, what role do they play in the formation of tors? What role do they play in the formation of tors? I'm talking about your batholith, I'm talking about your laccolith. What role do they play? 2.4.4. So igneous intrusions are the bedrock in which tors have their base. They are the bedrock of which the tors have got their base, which means it developed from here. Remember, before it was a batholith. Then what happens? Since now there's change in temperatures, the joints and cracks starts to form, which are horizontal and vertical, as you can see, which means already when it's still within the crust, of course, they are already core stones, but the moment it's exposed due to erosion, that's where we can see this coming off. Okay, so we are saying now the role that the igneous intrusions play in the formation of tors is the igneous intrusions are the bedrock from which tors have their base. They develop from a batholith. That's basically what we are talking about. Okay, the base rock undergoes chemical weathering along joints that form core stones under the surface. Okay, so the core stones, these are formed already under the surface due to chemical weathering. It's only now when they're exposed that you see them looking like this. That's basically what we are talking about. Then in a paragraph of approximately 8 lines, explain the formation of tors. How are the tors formed? I think I've already answered that question, but I'll just go through again. Okay, so the seeping water, remember, this is still within the earth crust. Chemical weathering, what happens? The seeping water, groundwater enters cracks. So the seeping water enter the cracks, okay? Enters the cracks and the joints of the granite rock, this batholith, okay? And underneath the surface, this is still within the crust, okay? This is what happens within the crust. It's intrusive, okay? Minerals in the rock become dissolved to form a solution. The minerals within the rock become dissolved to form a solution. Okay, they become dissolved to form a solution. I can talk of hydrolysis as a form of chemical weathering. Hydro, it means water. Lysis, it means the breaking down of rocks with water. So this is what happened. The rock is made up of different mineral components. Like your igneous is made up of feldspar, mica. So they react differently. That's basically what we are talking about. So this is what weakened the rock. Minerals in the rock become dissolved to form a solution, dissolution, okay? The rock underneath the ground becomes weak as well because it is chemically eroded. The removal of overlying rock layers exposes the core stones of the igneous rock. So we are saying now it starts off as a batholith. Of course, just below the crust is still intrusive. But however, as the water seeps down, okay, just because of it's slightly below the earth crust, it means now the temperatures are changing because where this material used to be in the mantle, it was in liquid state or molten state. Now it's within the crust, it's solidifying below the crust. The temperatures are different. Tracks start to develop, joints start to develop, which can be horizontal and vertical. So the water will seep, okay, as there is infiltration, there is percolation, the water will seep into the cracks and joints underground within the crust. So it means this result in chemical weathering taking place, which weaken the rocks, okay, resulting in the formation of these core stones. And when erosion takes place, then we are now having our tors. That's basically what we are talking about. That is it in as far as tors are concerned. Thank you.